you could be in a pickle. So you got to prepare for that. Pyreps matter. Winds already gusting to 36. That'd be, I wouldn't. Nope. Hey there, welcome back to AeroSafe. Today is February 25th, 1736 Zulu. We're gonna go through the weather briefing today using the AeroSafe weather brief checklist. Look at the weather across the country, talking about VFR areas, IFR areas, and some hazards that could exist within those. Our surface analysis. This gives us an idea of high pressure systems, low pressure systems, fronts, troughs. The East Coast, lots of high pressure, cold front down over Florida. High pressure also in the Gulf, there where the Mississippi comes out. Farther east, we do see some isobars, which are showing a gradient towards some low pressure systems, where we see some troughs, we see stationary front, an occluded front, and a low pressure up over the Great Lakes. Looks like the surface low there is 998 millibars. Not super low, but still going to be producing some yucky stuff, especially as it's connected with that occluded front, which is where three air masses meet. That cold front has advanced onto or over this stationary front, and where it meets we have the occluded front. Now occluded fronts usually produce some pretty yucky stuff, which we'll see in a moment when we look at categorical reports. So low pressures and fronts across the middle part of the US. Then as we move a little bit farther west over the Four Corners, we see some high pressure isobars very close together here. Now when there's isobars close together, that means the gradient is stronger between high pressure and low pressure, as the air seeks homeostasis. So it wants to be equal and even throughout in terms of pressure and temperature. That air is going to be moving from high pressure to low pressure. The closer those isobars are together, the stronger the wind will be. We'll see in a moment what that's creating over these mountainous areas. Over Idaho and Montana, got isobars that are pretty close together as well. High pressure over Oregon and Northern California. Way off the coast, quite a few large troughs, and low pressure over Northwest. More low pressure with an occluded front and a cold front that's going to be making its way down. Now we're going to look at how that surface analysis chart is actually creating weather patterns that we can see pertain to us as 100. So that's a very strong wind there. Looks like they do have 318 and 36 runways at Memphis, and the wind is 190. So a vast majority of that 12 knots gusting to 23 is going to be headwind component. So if you lived in that area, you'd want to be sure that it was within your personal minimums in terms of total wind component and crosswind component. The TAF says that wind is going to shift to a more southwesterly wind rather than straight southerly. So you'd want to be prepared for a contingency. What if that wind shifts more than you're comfortable with? What would you do? Not unmanageable, but you definitely don't want to be in those conditions for your first time solo if the most crosswind or total wind component you've ever flown with was, 12 to 15 knots. That would not be a safe way to expand your personal minimums. Most of the country is VFR, Washington to some tiny little bits of Minnesota, and we're beginning to see the development of some ceilings. So these green circles, for instance, here on Bozeman, indicate VFR conditions. So we've got a ceiling more than 3,000 and visibility more than 5 miles. But because it's filled in, it's a solid green circle, there is a ceiling. And that ceiling is overcast at 7,000. Winds 230 at 6, 10 miles of visibility. Ooh, but you also want to check the TAFs, right? At 2300 Zulu, wind's going to be 22 gusting 33. And then there's a 30% probability of visibility decreasing dramatically to 4 miles, snow and rain and mist. And then it gets even worse. 280 at 26, gusting 45 knots. Wow. Winds already gusting to 36. That'd be, I wouldn't. Nope. If we look at the surface analysis again, there's a few things that are creating this kind of yucky stuff going on at Bozeman. The trough, the close isobars, and then also the stationary front that's going to be moving in and down. Northern Idaho, we've got some marginal VFR areas. Coeur d'Alene is marginal VFR, broken at 2200 and overcast at 2800. 4 degrees on the surface. If it's 4 degrees on the surface and we have a relatively low ceiling at 2200, it is reasonable to then think that we're going to have icing air met. To recap, California to Maine, VFR. Now that doesn't mean that we aren't without hazards in that area. We're going to dive a little deeper into that in a second. And then IFR would be the Northwest from Washington over to North Dakota, with weather deteriorating in that area. Next thing I like to look at is the AirMet Zulus and the freezing levels. This gives you an indication of the lowest altitude at which outside air temperature is freezing. If you are in an airplane that does have structural anti or de-icing equipment, be sure that you're well trained with that equipment, that you've been in it before with a more experienced pilot, fully understand the limitations of your structural anti and de-icing equipment, and you have a plan that takes you into better weather, not deteriorating weather. We use things like the instrument rating and equipment like Weeping Wings to take us from areas of marginal weather into better weather, or to get us out of a situation, not put us into a bad situation. The areas where there were some ceilings also coincide with AirMet Zulus, which is very normal this time of year. So we've got this big bubble of freezing air on the surface that stretches down from Montana. So if you are in a cloud in that area, from the surface and up, you're going to potentially experience icing. A moderate severity of icing, bases at 4,000, tops at 18,000. Now that doesn't mean that you won't encounter ice below that. Bases at 4,000, tops at 15. Base at the surface for this one, tops at 13,000. Over Western Tennessee and Kentucky, bases at 7,000, tops at 16,000. This AirMet you could reasonably fly under. You could be well below the freezing level while remaining above obstacles and terrain, be in a cloud while not putting yourself in the position to accumulate ice. But you would want to check your low IFR charts and make sure that you're staying above the MEA, or the off-route obstacle clearance altitude, if you're doing a random route like a GPS Direct 2 route. Freezing levels are largely based off of models, not actual data, so they're not going to be exact, which means that you want to allow some margin of error for yourself. If you start getting into a position where you only have like 1,000 or 2,000 foot window between MEA and freezing level, but you're going to be in clouds the whole time, that does not give you a way to get to a safer place should you start to encounter some structural icing. This icing AirMet, you could reasonably stay below it. The others, not really. Pierce, South Dakota, 170 at 6 knots, 10 miles of visibility and clear, 9 degrees on the surface. They are predicting some clouds, but they're going to be high level. So while that is within the depiction of the graphical icing AirMet, you could go from there and fly south away from the yuck that's coming and maintain cloud clearance, but be above the freezing level, right? So outside air temperature is freezing or below, because the freezing level is here, you're above it. It's colder the higher you go typically, unless there's an inversion. That could be a situation where there's an AirMet, but the AirMet isn't automatically no-go. Those AirMets, especially this time of year, should give you pause and reason to kind of slow down and further delve deep into what exactly you're looking at. All right, let's look at AirMet Sierras. Those are going to kind of coincide with our IFR areas. The red AirMets are IFR conditions, and the purple are mountain obscuration. Mountain obscuration means that we can't see the mountains because of mist, fog, or precipitation, or clouds. And if you can't see the mountains, you can't easily avoid them. IFR procedures are written to help us maintain separation from other traffic and obstacles and terrain, but the procedures only work as well as you follow them. We see those here, and they're in the same areas where we saw AirMet Zulus. Low ceilings, icing conditions, not looking too good. We look at the AirMet Tangos. These give us turbulence, both high and low, sustained high surface winds, low level wind shear. Green areas are high level turbulence. While those start at flight level 180, they don't particularly apply to us, but they do give us an indication of the overall stability in the atmosphere. Yellow AirMets are low level turbulence AirMets. This one starts at the surface, as does this one, up to 180. Orange here is going to be sustained surface winds greater than 30 knots. Very windy over there. A result of these isobars that are super close together. I've never flown a light piston plane in mountainous areas, but I do know there's kind of a rule of thumb about surface winds being a certain velocity and mountain wave. If we bring up the center weather advisory, we do see mountain wave advisory here, reported by aircraft and visible on satellite. Yucky. Turn on SIGMETs. We don't see any over the contiguous US. Okay, anytime you see PIREPs outlined in red, that means it's a really big deal. Low level wind shear, plus or minus 10 knots and sporty. One over Michigan here, low level wind shear. Cessna 172, very applicable. Low level wind shear, minus 15 knots between the surface and 100 during the climb. Obviously, if you were going on an actual trip, you'd want to look at PIREPs near or along your route of flight. Be mindful of the type of aircraft, the altitude they were at, and what the remarks actually say. PIREPs are very important. I learned recently that they're not just important for telling other pilots what's going on. PIREPs are also very important for letting forecasters know what conditions actually exist. If they put up an AirMet for turbulence and they don't get any PIREPs at all, while that AirMet is up, they might think that they got it wrong. I gave a PIREP the other day with my friend Lydia. We were on a cross country, hopped over to flight service in flight, gave a PIREP. And by the time we made it home, the PIREP was visible. PIREPs matter. It's a way that we have communication between pilots and forecasters. So very important to file those, even if it's calm and clear. So if you were flying around, you definitely want to look at those PIREPs and get an idea of what may pertain to you and how you can use that information to make safe decisions. If we look at the AeroSafe weather brief checklist, we've looked at surface analysis. We'll look at prog charts in a moment. We've looked at SIGMETs, AirMets, PIREPs, freezing levels. We'll also look at cloud coverage on aviationweather.gov. This is a really great depiction of where clouds exist, which is really great if, say, you're departing IFR and you want to know if you can get on top of the clouds or not. For instance, in my neck of the woods, there's this little area of cloud. Bottoms of them are pretty high, 10,000 feet, just a couple thousand feet thick, it looks like. You could reasonably stay below that and remain with your VFR cloud clearance requirements perfectly safe. Now, there was an AirMet Zulu, West Tennessee, Western Kentucky, I think started at 7,000. So as long as you were below the freezing level and well above obstacles or out of the clouds, which you could be, you'd be fine in that area. Moving farther north and west, clouds are starting to come down. Okay, we looked at cloud coverage, we looked at freezing level, winds aloft. Give you an indication of what your ground speed will be. So we get our performance calculations from our POH, and then we combine that with the winds aloft at our cruise altitude, and we can then calculate what our ground speeds will be for each leg, and then our time en route, and then in combination with our performance charts, our fuel burn for each leg. Here at 7,000 feet, we do see some pretty strong winds over here. 45 knots at 7,000 feet from kind of a west-southwest direction. It looks fairly light through most of the US though. Far northwest, we got a 40 knotter. Of course, this is one of those things where you'd need to plan your route and look more in depth at your route and near your route. You need to know if conditions are deteriorating or improving so that you can prepare. Maybe increase your margins a little bit, because what if you were forecast to have a 25 knot headwind, but in 5 hours it was forecast to be 50 knot headwind? What if that forecast isn't quite right and those stronger winds come moving in sooner? You could be in a pickle. So you gotta prepare for that. All right, aviation surface forecast. This gives us an idea of surface conditions in terms of winds, including gust factor, the red portion of the barb, and it also tells us AirMets. 3 hours from now, we're seeing fairly strong winds on the surface, largely southwesterly, stretching from Texas to New York. And then we see a shift to mostly westerly throughout a large part of the country. It's kind of all over the place here. We see the AirMets we talked about earlier. Strong winds are coming in, and IFR, and there would also be some Zulus in there associated with that. So it's going to remain yucky up in the northwest for a little bit, clear on the east, but strong surface winds. We already looked at the METARs right after the surface analysis. The last bit of this that you would want to do if you were actually going on a flight is calling 1-800-WEATHER-BRIEF. Talk to a real person to get an idea of, is there anything that I'm missing here? Am I making a good decision? So that's the last piece of any good solid weather brief. If we look briefly at surface prog charts, just to kind of get a forecast of what's going to be happening, cold air is going to come in over the Great Lakes area, followed behind with some high pressure. A series of troughs stretching across the west, and a pretty big low over the northern border of North Dakota. Cold front over the Pacific Ocean, a lot of precipitation over the northwest, and the possibility for some thunderstorm. So the northwest is getting slaughtered. Again, 2 days on Tuesday. Basically, the whole west has a chance or likelihood of precipitation as a result of those cold fronts and low pressure systems. The east is still looking pretty good. At that point, but it's going to be very windy. We're not out of the woods yet, obviously, in terms of winter. Large portions of the country are still going to have cold and snow and yucky stuff. It does feel, at least here in Kentucky, like we're moving into early spring. We get more blue skies. I think it's natural that we all start looking up a little bit more. So as you've been looking up or waiting for days of blue skies that you can look up to, I'm curious, for the sake of getting some AeroSafe swag, what goals do you have this year in your aviation journey? Are you aiming for a new certificate or rating? Is there an endorsement that you want to get this year? Total hours number that you're wanting to hit? What are your goals this year? My goals this year in terms of aviation, helping others reach their goals, helping them better understand weather and decision making as a pilot. I also have a goal of trying to better build some aviation community, and one of the ways in which I'll be doing that is on March 16th at the Danville, Kentucky airport. At 11 a.m. I'm going to be giving a talk called How to Make Your Dreams Take Off. I'm going to be sharing a little bit of my story, providing a little bit of motivation for you, and then wrapping that up with some practical tips and tricks that you can use to help accomplish your goals. If you feel like you need that, or maybe there's someone in your life, maybe a niece or a nephew or someone that you want to feel inspired, please feel free to bring them out March 16th, Danville, Kentucky, 11 a.m. I think it's super important that we continue to inspire the next generation of aviators, someone who will let us fly with them when one day we're no longer able to. Thanks so much for tuning in, and we'll see you next time.